Future self. You have to see. Also, hi. You have to see what Steven... Look, there's the doggles. What Steven made. This is Steven.
Hello.
And he made... Okay, so... Notebook. Green screen. Webcam. Move the webcam around. Take lots of pictures. Then take out the green screen using algorithms. Then fill in the green screen with flood fill with random color selection. We have to make it bigger. You have to zoom it. It's so pretty. Oh, and each one of them is like totally different. And they have all these like little amazing blobble bits. Oh my god, they're so good. Hang on more. What is it clicking? Oh yeah. This one is so good. Oh. I mean, look at those colors and all those lines. Oh my gosh. It's like accidental algorithm arts from... Whoa.
Accidental algorithm art from who?
From Steven.
Oh.
Okay, so the reason that this is happening is that... Okay, tell me if I explain it incorrectly. We want to train a personalized Yolo, you only look once, algorithm, so it can recognize every page of the journals.
You want to train
to do that,
a neural network using Yolo v3 so that it can recognize each page individually in any orientation and any environment, so that as people flip through, right, can identify the pages, and then that can link to other content.
So, and this image is happening because we want to have an image where the background could be literally anything. Like the notebook could be anywhere, right, on any surface.
Because otherwise, so to streamline things, oftentimes for computer vision, people will use something called data augmentation. So they'll have a picture of a cat, and they don't have a bunch of pictures of that cat. Or they scrape for a bunch of different cats, but to like sort of floof the data up more and get the most out of it, they do a bunch of just transforms on that image set. So they'll do skews, and they'll like do zoom ins and zoom outs, and they'll in pans and tilts and skews, and they'll like pick random portions of the image.
And we're doing basically all of that by just like hand holding a camera and moving it around.
Rather than doing all of that, I figured, well, why don't we just take a webcam up to the notebook? Because that would be kind of a pain. First of all, just capturing the images of the pages would be a pain because we'd have to shoot it in like a bunch of different environments, which is a pain in the ass. And then do the data augmentation. So I was like, well, why don't we streamline the actual capture by just taking a webcam to it and going we're
getting more,
but it's faster, and then you save up frames from that video. So to get around that, that's really fast. That part's really fast. But then the problem you now have is that they're all shot on the same background.
Right.
So to get around that, I shot it on green screen. Then the problem you now have is that they're all shot on the same background.
Right.
So to get around that, I shot it on green screen, pulled out the green screen, and then but now you have even blander background because it's just like black or transparent or something. So then to make it so that which means and the reason that's important is intuitively, based on what I understand about Yolo and computer vision in general, seems like you'd basically be training the network to recognize it specifically in a black background, and you want it to be able to recognize it in any background. So to simulate a background, since that's the part that we can't actually, like in the real world, automate, I decided to just add random noise to the
But
background.
real good random noise.
But if you think about it, you don't want to just, every pixel is a random color, because then it's like, Technicolor TV static, which is not very helpful, probably. You want like chunks of color. So then I was thinking of how to do that, and then I realized, I was going to like process it after, like, oh, maybe I don't set the colors until after I've identified all of the flood fill pixels, right?
Mm-hmm.
So one of the artifacts of the code is that you have an array that tells you, that has a Boolean value that tells you that, all of these pixels, this set of pixels have been visited. It is basically identifying the flood fill pixels so that you don't visit them again. And then I realized, but, of course that would like double the length of the algorithm or something like that.
Right.
So then I realized, oh, wait a minute. I'm thinking about this wrong, because I was thinking of it in terms of like a nested for loop, right? Of like scanning down in lines. And then I remembered that, actually flood fill doesn't work that way. Each pixel processes itself, and then it chooses all of its neighbors that are part of the green screen in each cardinal direction. And then the loop goes back to the beginning, and it just pops, the first thing off that list. So this is interesting because I did it just for random noise, because I want to, you want these contiguous chunks of color, right? Rather than, like I said, just like each pixel being unique. And I was thinking it would be more like blobs, because intuitively I thought of the flood fill based on the logic that it would sort of like expand in a spiral like this from each point. But obviously that's not the case. So it had the unintended consequence of side effect of visualizing
the flood fill.
Flood fill actually. Flood fill actually works a lot more chaotically than.
Yeah, it's so pretty,
than
and they're each one of them is like so gorgeous.
And you can look at it in at like a high level and compare them, and you're like, oh, they're kind of similar. But then when you inspect each one, they're actually indications that no, they're kind of unique. Like there's certain patterns, high level patterns that are kind of consistent.
These little stripy
things. But the way
things
they kind of roll out is actually not. There isn't like it doesn't. There's nothing that's like particularly intuitive. Like if you zoom out the scroll wheel, like this chunk here. So there's this big chunk, and it has certain like it has this hard line. But then there's this bit here, like this color is the same as these colors. So these are those color. That's part of the same color chunk.
Yeah, because each color chunk is the color is only chosen once. So this is all thought of as
so
one
it's just
bit.
It doesn't make any sense really when you think, or like this one, this yellow over here. You've got this like umber, or no, I guess it's ochre. It's ochre color here, but then you got it here. So like those are this together.
Yeah.
And it's interleaved with this. It's wow.
It's amazing.
And you've got these like growing these artifacts. You still recording?
Yeah.
Was it black?
Oh, that's the UI for using the camera.
Oh, gotcha. So you got these artifacts where it looks like it's growing. And this occurs, by the way. I noticed that this tends to occur on blurry images, so it has a hard time differentiating. It's kind of funny, like the green from the green screen, I guess, kind of bleeds in because of the blurriness, which is interesting. That's another interesting artifact. So we actually don't know if with this random noise and the blur effect, we actually don't know. We haven't trained it yet. We don't know if this will actually work. I think it will, but it might not. Oh, look at this.
Oh yeah, that's the other thing is we don't know if this will actually train.
I think it will, but it might not. Look at this one though. I just noticed this. This one looks 3D. It looks like 3D steps.
Oh wow, yeah.
It's like a 3D waterfall. Oh, that is so cool. That is awesome. And it repeated this pattern with different colors. It's fascinating.
Yeah, it's so pretty.
Like just when you think like, oh yeah, I understand what's going on here, you get pulled back in. It literally, even this, it looks like there's another waterfall going off that side. Ah, man. So cool.
Turns out when you do arts to things, it shows you that it is a thing that you didn't think it was before.
I can't really show this unless I start over from another batch. I guess I could create a copy of the batch, but I added audio output just as an indicator to me, because
we can just communicate a bit. How is the song? How does the song go?
So
I'm making a new image for you. Boop.
Yeah. So the debug log statements in Unity, they don't work real well, and this is true in pretty much any library. Like printing out to a console or something doesn't work very well inside a while loop or even a for each loop. So I wanted a different indicator to kind of tell me about progress. So like every 10% of processing of one of these images, I emit like a sound, and I emit another sound like a beep at the beginning and another system sound at the end. So yeah, what it kind of sounds like is boop doodaloo 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 doodaloo
Boop.
That's what it does. Yeah.
It's really fun.
Over and over again.
Oh, I'm so excited to train with this thing and also to print these out on the wall and make them massive.
But that was actually kind of
so
nice
pretty.
because there was no progress. I couldn't get any visual progress hooked up to this,
But we could do, if we do want to print these, we could take very high resolution photos and do it with that. Like,
well, they're pings. You can just print straight from a ping.
Well, I know, but I don't know how big these are. Anyway,
they're 640 by
it's
40.
very exciting.
Very big.
The arts that are happening is all very exciting.
Yeah.
Okay, bye, Sal.